going to do number 3 to start off with. What's the mass of the student on the left side of the teeter-totter? 2.8 in length. 1.1, 1.4. I think this was all nicely supplied. Yep. Just double checking we didn't mess anything up. Total mass of the students is 72 kilograms for me. So that I need to. Yeah, I have 72. Assume the teeter-totter itself proves the second. That means the center of mass of the teeter-totter is in the center. And I don't have to worry about its mass. All right, so in an effort to just be quicker, I'm going to just write down my physics equation. M1 x1 plus M2 x2 over M1 plus M2. Right? And I'm interested in M sub A, the left person on the left. All right? So, and for my diagram, nicely I know that the center of mass is in the center. Where do I want to measure everything from? The left from here? Okay. So I'll use that as my point A. So that means this is 0.3. Right? And so my center of mass is 1.4 meters away because it's at the center, right? Mass 1 is mass A, and it's 0.3 meters away. Mass 2 is mass B, and it is 2.8 away. 2.8. And that's all going to be over 72. Now I'm going to now could we solve that? Sure, because we've got this one equation and we've got this equation. They both have M1 and MA and MB in them. Two equations, two unknowns, solvable, right? I'm going to make our life a little simpler. I'm going to put our center of mass right here. Our reference point. So this will all be done in red. And I'm going to call to the left positive. Can I do that? Sure. I am the master of the physics universe. Same equation. Center of mass is still 1.4 meters away. Mass A is now 2.5 meters away. 1.4 to the center, and then 1.1 beyond that. Good? Plus mass B, which is 0 meters away. And 72 kilograms on the bottom. That way, how many unknowns do I have? 1, and it's the one I want. Yay! Right. So that's why I picked over there, because I knew it would get rid of it. And that's just something that comes to practice. The other one, completely solvable. A little more algebra practice, get you ready for that math test a little better. This way, I'm just off to watch Netflix soon. Yep. So I'd get 72 kilograms times 1.4 meters equals MA times 2.5 meters. And then I would just solve for M sub A. And I would be happy. Yay! All right. So we're going to look at number 12 here. What altitude above the Earth surface is gravitational field strength equal to G over 2. And my guess is you have different values for G over 5, something like that. Okay. I'll do 2. So, from my equation sheet, I don't have it pulled up, but, and I don't expect you guys to remember these, but I remember them. G equals G, mass of the planet, radius squared. All right. Remember, it's only raised to the planet if I'm standing on the surface of the planet, right? So mine over here is 9.81 newtons per kilogram over 2. That's the value they give me of the gravitational field strength. My G, I'm in this universe, so 6.67 times 10 to the negative 11 Newton meter squared, kilogram squared. Mass of the planet is whatever the mass of the Earth is. I need to look that up. And then my radius is the radius of the Earth plus whatever altitude I'm at squared. 9.81 newtons per kilogram. No, that's the gravitational field strength of the surface of the Earth. And since they told me, books a lot of times use little g just as, the shorthand for, well, gravitational field strength. But if I'm on the Earth, I know what the little g of the Earth is. It's on my equation sheet also on the final page. And so I'm just going to rearrange this, do a little bit of funky math, right? RE plus alt squared equals 6.67 times 10 to the negative 11 Newton meter squared, kilogram squared, mass of the Earth, all over 9.81 newtons per kilogram, which is over 2. Now, really, I only have one variable in there, right? It's radius of the Earth. I look up on my equation sheet. What unit should I make sure it's in? Meters. And the mass of the Earth, I look up, and it should be in kilograms. So, oh, wait a minute, that's squared. What do I have to do to get it out of the squared? Square root. So, I'm going to end up with alt equals the square root of my 6.67 times 10 to the negative 11 Newton meters squared, whatever the mass of the Earth is. I did the divide by 2 in my head. All multiplied, all minus radius of the Earth. Make sure when you're doing your math that minus the radius of the Earth is outside the square root, right? Be careful of that. And they want my answers in meters, so I don't even have to convert at the end.